So we've already learned how to translate, move things left and right and up and down. But now we're going to learn how to take our parent functions and stretch them horizontally and stretch them vertically. So hopefully after today, you're able to take any of those parent functions, like we have listed here, and stretch and shrink them. So just like translations, which was shifting right, left, up, down, we can also stretch or shrink our parent functions vertically and horizontally. The notation here looks similar to what you saw with translations, except that was adding inside or outside the argument. Here, when you stretch or shrink, and here's the important part here, when you stretch or shrink, you are multiplying inside or outside the argument. So adding and subtracting, that causes a shift. You just move your function left, right, up, or down. Multiplying by some factor inside or outside the argument causes it to stretch or shrink, meaning it causes the graph to get wider or narrower. It doesn't move it around the coordinate plane. It just changes how wide it is or how narrow the opening is. Say if it was a quadratic, it might make it look wider or narrower. So how does this work? We'll start with inside the argument. So this is inside the argument. So inside the argument, if you multiply by a number, that is going to cause, again inside, it is a horizontal stretch or shrink. Outside the argument, like this a value, will cause a vertical stretch or shrink. So how do you know? So first of all, you got to understand, okay, am I changing or stretching or shrinking my graph horizontally, or am I stretching or shrinking my graph vertically? Remember, anything inside your argument changes your x values. Anything outside the argument changes your y values. So if we multiply by something inside, I'm going to have to multiply something by my x values. If I multiply by something outside, I'm going to have to multiply a factor by my y values. So how do you know or determine if it's a stretch or a shrink? So first let's talk about the horizontal stretch or shrink. If it's inside the argument, you're going to multiply by the reciprocal. You're going to multiply your x values by the reciprocal. So what does that mean? So if your b value is greater than 1, so if your b value is greater than 1, that is actually going to cause a shrink. If your b value is between 0 and 1, like a 1/2 or a third or 3/4 or something along those lines, that's actually going to cause a stretch. And you might think, wait a second, so multiplying something by, say, a value of 2, which is bigger than 1, if I multiply something by 2, it gets smaller. If I multiply something by, say, a half, it gets bigger. Well, again, right here is the key. Multiplying whatever your b value is, you're going to end up multiplying your x values by the reciprocal of that number. So think of it this way. If b was 2, that means you're going to multiply your x values by 1/2, because the reciprocal of 2 is a half. And multiplying by 1/2 causes things to get smaller. Same way, you can think of it as, just one more example, if your b value was 4, that means you're going to have to multiply your x values by 1/4. So you're cutting everything into fourths. So that's why a b value bigger than 1 causes what we would call a shrink, whereas a fraction like a half, if your b value inside your argument was a half, that would mean that you're going to multiply your x values by the whole number 2, which would cause it to stretch. So that's why, again, just like translations, how it was the opposite sign of what you saw inside you had to do, here, for multiplying, it's the reciprocal. Again, similar to translations, if you remember translations, if you added outside, it went up. If you subtracted outside, it went down. Same kind of rule applies to stretches and shrinks when you're outside the argument. If you've got a value bigger than 1, that will cause a stretch. And if you have a value in between 0 and 1, that will cause a shrink. Okay? So again, outside, what you see is what you get. Multiply by something bigger than 1, you're going to make it bigger. Multiply by a fraction like a half or a third or a fourth or 3/4 or something in between 0 and 1, you're going to make it smaller. That'd be a shrink. Okay, so always works a little better when you're looking at it in equations. It might make a little bit more sense. So let's look at each one and describe the stretch or shrink that's going on. So number 1, I see the squaring function. And remember we talked about with translations, the argument for a squaring function would be when it's inside the square. That 2 is not inside the square. So therefore it would not be in the argument. That 2 is considered outside the argument. Outside the argument, it's like an a value, so it's vertical. So to describe this, I would call this a vertical, because I got to give it direction, and then I got to call it a stretch or a shrink. A 2 is bigger than 1, so it would be a vertical stretch of factor 2. So when I describe the stretch or shrink, I have to say vertical or horizontal. I have to call it a stretch or shrink, and then I have to say what it's a factor by. So I'd be multiplying by 2, so it's a factor of 2. Let's look down at number 2 here. Number 2 is a square root function. That 1/2 is obviously outside of the argument. Outside would be vertical again. Now it's in between 0 and 1, so that's a shrink. And that would be of factor 1/2. Let's look at number 3. Number 3 is an absolute value equation. The 4 is clearly inside the argument. The argument in an absolute value equation would be the absolute value bars. So if it's inside the argument, now all of a sudden I'm talking about a horizontal change. So that'd be a horizontal, and again, for horizontal changes, if your b value is bigger than 1, which it is here, it's a 4, it would actually cause a shrink. So it would be a horizontal shrink of factor 1/4. When we list the factor, we list what we would actually multiply our x or y values by. So since it's a 4 inside, anything horizontal, I multiply by the x, I multiply my x values by its reciprocal. It'd be a horizontal shrink of factor 1/4. So number 4 is a cube root function. Clearly my changes are happening inside the argument, so it's horizontal. Would it be a stretch or a shrink? Well, I have x over 4. It's kind of like dividing by 4, which is the same thing as multiplying by a 1/4. So dividing by 4 is like multiplying by a 1/4. So it looks like the b value in this case would be in between 0 and 1, which would cause it to be a stretch. And then of factor. So if my b value is a 4th, I'm multiplying by the reciprocal of that, so of factor 4th. So that's just looking at an equation and being able to describe what's going on. Now let's actually try to graph some stretches and shrinks. So here we go. We've got a simple quadratic or squaring function. Again, first ask yourself, is it a horizontal change or a vertical change? Meaning, is my factor in the argument or out? I see a quadratic. It doesn't look like there's any changes inside the argument, so that's definitely vertical. So that'd be a vertical stretch, because my a value is bigger than 1, of factor 2. So here we go. We're going to graph, and just like translations, we always start with our parent points. So I'm going to make a table with the parent points for the squaring function, which you should all know by now. Okay. Now, anytime you have a vertical change, that affects your y values. So what I'm going to do is I'm going to take my y values, and it's a factor of 2. I'm going to multiply them by 2. So these are going to stay my x's, and my y's are going to change. That's a 4 there. So 4 times 2 is 8. 1 times 2 is 2. 0, 2, and 8. So these are now my new y's. So my new order pairs go -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. So now I can graph it. -2, 8. -1, 2, 0, 0, 1, 2, 2, 8. So we called this a vertical stretch. You can kind of see how it's being, if you think about it, sticking to the x or the origin, and you taking the top extremes of the graph and pulling it up vertically. You can kind of tell if we graph the parent function right next to it. Here's the parent function. So here's the original parabola. So now you can kind of see how it's called a vertical stretch because it's being stretched up, which makes it narrower. So again, it's just as easy as taking your parent points, recognizing the stretch or shrink in the equation, and multiplying those values. Let's try another one here. So this one is a cubing function. Again, ask yourself, am I doing something vertically or horizontally? This is definitely inside the argument. This is a change inside the argument, so it's going to be a horizontal. Now stretch or shrink, which one would that be? A b value that's in between 0 and 1 would be a stretch of factor, and again, my b value, I multiply my x's by the reciprocal, so the reciprocal of 1/2 would be 2. So I'm going to make my table here with my parent points for the cubing function. And then any horizontal changes are going to affect my x values. So like we said, if it's a horizontal change, you multiply by the reciprocal of your b value. So I'm going to take all my x's and I'm going to multiply by 2. So -2 times 2 is -4. -1 times 2 is -2. 0, 2, and 4. So these are my new x values. Nothing changed vertically. So these are still my y values. So be careful when this happens because the table is kind of in reverse order now. I got to do x comma y. So I'm going to graph really quick the parent function just so you can get some perspective. Of the change. Again, horizontal stretch, which means you're pretty much pulling it from the left into the right, and from the left and right. So here we go. -4, 1, 2, 3, 4, -8. -2, -1, 0, 0, 2, 1, and 4, 8. So you can see how it got wider because it's a horizontal, you're stretching it horizontally, you're like pulling it to the left and to the right. All right, one last graph here. Notice you can definitely see that there's 2 factors being multiplied here. So we actually have 2 things going on. First, I notice I've got a 3 outside. Anything outside would be a vertical change. It's a 3, so that's bigger than 1, so it's a vertical stretch of factor 3. And then inside, I've got a horizontal. It's a 2, which makes it a shrink. Because think about the reciprocal. It's going to be a shrink of factor 1/2. So let's make our points. This is a square root function, which only has 3 parent points, 0, 0, 1, 1, and 4, 2. Now I'm going to need 2 more columns because I am making 2 changes. I'm going to take my x's, which is the horizontal change, and I'm going to multiply that by 1/2. I'm going to take my y's, which is the vertical change, and I'm going to multiply that by 3. So I'm going to have a brand new set of x values and y values. So that'd be 0, 1/2, 1 times 1/2. 4 times 1/2 is 2. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. So there are my new order pairs. Once again, just for perspective here, I'm going to draw the parent function. Do you always have to draw the parent function? You do not unless it's stated. Normally you do not. So here would be the function. 0, 0, that's not going anywhere. But now 1/2 comma 3, and then 2 comma 6. So that looks straight, but it's not a straight line. So I'm going to make sure I still get that curve in it right there. Okay, so there we go. So sometimes you'll just have a horizontal change, sometimes you'll have just a vertical change, but sometimes you get both in there.